All right, so here we got apples, and it says suppose that a certain variety of apples have weights that follow a normal distribution. The mean of 9 ounces and a standard deviation of 1.5 ounces. If bags of apples are filled by randomly selecting 12 apples, what is the probability that the sum of the weights of the 12 apples is less than 100 ounces? All right, so first thing we're going to do here is cross out apples. I actually don't like apples. I'm going to change this to oranges. And so now I'm a teacher, but I do not like apples. Please don't ever bring me apples. And my students, please don't eat apples around me. I actually don't know why I don't like apples. Let's change. Oranges are good though. A lot of vitamin C. All right. Anyways, let's move on to the stats now. We want to find what's the probability that the sum of 12 oranges is less than 100 ounces. Now, we're told that the distribution of oranges have weights that follow a normal distribution with a mean of 9 ounces and a standard deviation of 1.5 ounces. Now, this isn't going to be as simple as, doing what we did in chapter 2, where we find the probability in the normal curve with mean 9 and standard deviation 1.5, because this is only talking about selecting one orange. We want to select 12 oranges and figure out what the probability of getting the sum of getting the total weight of being less than 100 ounces, and that's a different distribution. So let's break this down into some formulas and notation so that we can put this and make this more clear to what I mean. So we're going to let x of I be the weight of a randomly selected orange. Selected orange measured in ounces. And what we're trying to figure out is what's the probability of selecting 12 oranges. So 12 of these x of i's, adding their weights and it being less than 100. So we're going to have a new variable that we're going to call t, and t will be the sum of 12 randomly selected oranges, or the sum of x1 plus x2 plus x3 plus all the way till we have 12 oranges selected. Now, we want to then find the probability that t is less than 100. So our goal is to find the probability that t is less than 100. Not the probability that x is less than 100. So it's a different distribution, different variable we're actually talking about. Now, find this, we're going to need to find what the standard deviation of t is and what the mean of t is. So we need to find the mean of t. We need to find the mean of t and standard deviation of t. Once we know those, then we can use a normal distribution with the normal curve and table A to find the probability. So let's find first the mean of t. Since t is the sum of 12 random variables, we simply add the means of those 12 variables. So the mean of t will be equal to the mean of x1 plus the mean of x2. Oops. Plus the mean of x2 plus the mean of x3 plus all the way till we get to the mean of x12, the 12th apple. And this is just going back to the previous lesson where we have that if we have another variable that's equal to the sum of two other variables, like t is equal to x plus y, and the mean of t is equal to the mean of x plus the mean of y. So we just add their means together, and all of their means are 9. So, they're all the same, they're all the same thing, essentially. So we're gonna have essentially 9 plus 9 plus 9, We're adding 9 12 times. We're basically just gonna do 12 times 9. 12 times 9 will be 108. So the mean of t is gonna be 108. We got that down. Now we need to find the standard deviation of t. Now we're gonna first find the variance of t, because if you know the variance, you just take the square root of the variance and then look at the standard deviation. Let's first find the variance of t. The variance of t, going back again to what we did in the previous section, previous problems, we have the formula that if you have a variable that's the sum of other variables, like if t is equal to x plus y, then the variance of t is just equal to the sum of the variances of x and y. Just add them together. So in this problem, the variance of t is just going to be equal to the variance of x1 plus the variance of x2 plus the variance of x3 all the way to get 12 variance x12. All of those are going to be 1.5 squared because the standard deviation is 1.5. You're going to have 1.5 squared plus 1.5 squared, 1.5 squared, all 12 times because you're doing 12 oranges. And you're gonna get 27. Now, remember, this is the variance. To find the standard deviation, you're going to take the square root of the variance. So the standard deviation of t will be the square root of 27. That's going to be about 5.196. And so now we have the mean of t and the standard deviation of t. So now we can just basically apply what we learned in chapter 2 and find the area and a corresponding normal distribution, this mean and this standard deviation. So let's draw a normal bell curve so we can get a visual of what we're doing. So here we go, bell curve. Normal with a mean of 108, standard deviation of 5.196. We want to find the probability that t is less than 100. So if 108 is in the middle here, 100 will be somewhat to the left. Actually, pretty far to the left, relatively speaking. So we want to find the area like to the left of 100. So we want to find this essentially. That's our goal. That area will correspond to the probability that t is less than 100. So what we're going to do is standardize this to make it a z-score and then find the area to the left of that z-score by using the normal curve. So we're going to change this to normal distribution with the mean of 0 and standard deviation of 1 and find what that z value is. And then we can find the area to the left of that z value by using table A, and then we'll get our answer. So remember, the formula for a standardized score is just going to be z will equal the observation value. In this case, it's 100. So z will be, 100 minus the mean. So minus 108 over the standard deviation, 5.196. We're at about negative 1.54, it looks like. This will be negative. So using old school tech or using old school technology, meaning paper or textbook or table A, look at the value closest in negative 1.54, which we should have exactly negative 1.54. And we're going to get that it's about 0.0618. This area is about 0.0618. And so, in context, we say that the probability of selecting 12 oranges at random and then weighing less than 100 ounces is about 6.18%. There. 0.0618. Sum of 12 randomly selected oranges. And there you go.